Okay, good morning students. This is the 21st part of circles. Today I am going to explain another concept called radical axis of circles and radical center of a circles. Okay, see here, two circles are given here. Okay, first of all, a circle is given. From external point, we can draw two tangents. This is one tangent, this is another tangent. Their equations are different, but lengths are same. Lengths means tangent segments are same. This length equal to this length. This point is taken as x1, y1. Circular equation is s equal to 0. This length is nothing but root over s11. Or simply in circular equation, we need to substitute x1, y1. What we will get, that is s11. Root over s11 gives the length of the tangent segment. Okay. So now here two circles are given. Generally these two circles are not intersect each other. Okay. So from a point is taken on the same plane. Through this point you can draw two tangent to first circle. Okay. So what is the important thing here? For example, point of tangents is A and B. Say this is P. PA equal to PB. Through this point you can draw two tangent to second circle. These are the two tangents. Say this is some M and N. So what is the important thing? PM equal to PN. PA equal to PB and PM equal to PN. So these two are same and these two are same. Don't think that PA equal to PM, may or may not. That means from a point, if tangents are drawn to circles, the tangent segments may or may not equal. Listen students, the locus of a point, so that the tangents drawn from that point to circles have equal length, then its locus is called radical axis of these two circles. For example, these four are equal, then you can say that this is one of the point on the radical axis or one of the point on the required locus. Okay, listen students, two circles are given. There exist some points on the plane, so that from those points you can draw tangents to two different circles, their lengths are equal. Okay, so set of points or locus of such points is called radical axis of these two circles. Okay, now I want to prove that radical axis means locus of the point is nothing but a straight line. One thing, the radical axis is perpendicular to the line segment joining their centers. Two things I want to prove now. First one is radical axis is nothing but a straight line. Second thing is radical axis is perpendicular to the line segment joining their centers. Okay students, here I wrote the definition of radical axis. Radical axis, the radical axis of two circles is the locus of point which moves such that the lengths of tangents drawn from it to two circles are equal. Two circles are given. Generally we will take a non-intersecting circle. They may be intersect, that is not big problem. So two non-intersecting circles are taken. This is S1 equal to 0 and this S2 equal to 0. According to definition, we want to find locus equation, so that from that point tangents are drawn, there should have equal length. In this length should be equal to this length, such a way that the point P is moving. What the locus of P? That gives the radical axis. Actually radical axis is a straight line. I will prove it now. Now theorem. The radical axis of two circles S1 equal to 0 and S2 equal to 0 is S1 minus S2 equal to 0. Already observed, no? Equation of common chord, that also S1 minus S2 equal to 0 only. If two circles are intersect each other, then S1 minus S2 equal to 0 represent equation of common chord. So here what happened? What is my situation? First situation, the circles are not intersecting each other. In this situation, S1 minus S2 stand for equation of axis, equation of radical axis. I will prove. Observe here. two circles are given. Say this S1 equal to 0 and this S2 equal to 0. P alpha comma beta be a point. I will write, let P alpha comma beta be a point on required locus. Locus. What is the meaning of this? From here, tangents are drawn to first circle. Similarly, we can draw another also. That is not a big problem. So this is A. Say this is B. So what is the condition here? PA equal to mod. I can write mod PA equal to P. Sometimes we will get that expression may be negative. Mod PA equal to mod PP. Such a way that you want to find the locus equation of P. Okay, PA length of the tangent segment, root over S11. Just in circular equation, we have substituted alpha beta. Understood? So, first of all, I want to take circles are as, okay, next here I will write S1 stand for x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0, and S2 is taken as x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. Okay, no. So first of all, what I want? PL length. PL length means root over S11. Just we need to substitute alpha comma beta in the circular equation. That is alpha square plus beta square plus 2g1 alpha plus 2f1 beta plus c1 should be equal to root over alpha square. Just we need to substitute the alpha comma beta in the circular equation. What we will get? That is nothing but root over S11. So alpha square plus beta square plus 2g2 alpha plus 2f2 beta plus c2. Okay, squaring alpha square plus beta square plus 2g dash alpha plus 2f1 beta plus c1 equal to alpha square plus beta square plus 2g2 alpha plus 2f2 beta plus c2. Beta square alpha square get cancelled. So 2 times of g1 minus g2 into alpha plus 2 times of f1 minus f2 into beta plus c1 minus c2 equal to 0. So this is the locus equation. Now I want generalize. Instead of alpha I want to write x, instead of beta I will write here the locus equation. Is what happened? G1 minus G2 into x 2 times plus 2 times of f1 minus f2 into y plus c minus c1 equal to 0. This is the locus equation, required locus equation. This is in the form of ax plus by plus c equal to 0 under condition mod a plus mod b not equal to 0. So this is a straight line. Means our radical axis is nothing but a straight line. To the radical axis of two circles is the locus of a point which moves such that the length of tangents drawn from it to two circles are equal. Under this condition, the locus equation nothing but a straight line. The straight line is this. Okay, important note. How we will get this straight line? How to find this straight line? Just to subtract one circular equation from another. Okay, S1 minus S2 or S2 minus S1. What you will get? That is the equation of radical axis. Okay, if two circles are not touch each other or intersect each other or touch each other, no problem. For all the cases, S1 minus S2 equals 0 represent equation of radical axis. Okay, important note. Two circular equations are given. For example, so I will write here. Observe here. X square plus y square plus 2x plus 3y plus 4 equal to 0. One circular equation. Another one is 2x square plus 2y square plus 7x plus 9y plus 4 equal to 0 given. We want to find the equation of radical axis. Just we need to subtract, but should take care. So while subtracting these two, should get a linear equation. If you subtract directly, what do you get? X square plus y square equals something. So again another circular equation will get. What is the meaning of that? We want convert this one into standard form. Standard form in sense, I want x square and y coefficients are both are equal to 1. to eliminate x square and y square terms. After that only we want to subtract. Understood? That should take care. So I want to write one by one. Note the first one, the radical axis of s1 equal to 0 comma s2 equal to 0 is s1 minus s2 equal to 0. This is important. The radical axis is a straight line. Third one. So diagrammatically, if two circles are not touch each other, this is radical axis. Okay. If two circles are intersect each other, important, the common chord becomes radical axis. Okay, this is only the common chord, this is only the radical axis. Third one, circles are touch each other, the common tangent becomes the radical axis. Should take care. Here only circles are touch each other internally. In this case also, the common tangent is become the radical axis. Okay, fourth one. Here third completed. Fourth one. Radical axis is perpendicular to the line segment join centers of two circles. This is important, Nana. This is important. For this I want to prove, Nana. What is radical equation? Radical axis. What is radical axis? 2 times of g1 minus g2x plus 2 times of f1 minus f2y plus c1 minus c2 equal to 0. What is slope, Nana? Slope of axis. Axis means radical axis equal to minus a by b minus times of g1 minus g2 by f1 minus f2, 2 to get cancelled. So this is the slope of radical axis. Now circles are given here. First is center of first circle, that is minus g1 comma minus f1. What center of second circle? Minus g2 comma minus f2. Now I want to find the slope of line segment joining the centers. I can say cc1. Slope of c1 c2. Sorry, c1 c2. I can call it as c1 c2. So y2 minus 1 by x2 minus x1 minus f2 minus half minus plus f1 by minus g2 plus g1. So this is the slope of the line segment joining their centers, or in other words I can say that f1 minus f2 by g1 minus g2. Okay, so multiply these two. What happened? Observe multiplication of these two. So what happened? f1 minus f2 into g1 minus g2 into, so what is minus of? I will write here minus g1 minus g2 by f1 minus f2. Cancel, no? So what will you get? Minus 1. Therefore c1 c2 is perpendicular to radical axis. I can say radical axis. This is one of the important property. Okay, students, fifth note, radical axis bisects the common tangent of two circles. This is somewhat interesting one. Okay, observe here. These are two circles. This is radical axis. Okay, what is first fourth note? The radical axis perpendicular to the line segment joining the centers. One more thing is radical axis bisect the common tangent. Radical axis bisect the common tangent. So radical axis bisect the common tangent means this becomes the midpoint of this tangent. Okay, so this radical axis bisect this common tangent. For example, this is A, this is B. We want to prove that P is the midpoint of AB. Easily can prove by the definition of radical axis. What is the definition of radical axis? The tangents drawn from every point on this line to these two circles are equal. Automatically, this P is one of the point on the radical axis. This is one tangent, this is another tangent. Automatically, this should be equal. That's why radical axis bisect the common tangents of two circles. This is important. Here PA equal to PB. Okay, students, this note is very important. The locus of centers of circles which are orthogonal to S1 equal to 0 and S2 equal to 0 is the radical axis of S1 equal to 0 and S2 equal to 0. I want to explain. See here, two circles are given. They may be intersect, they may not intersect. That is not a big problem. Two circles are given. Now, we want to find the locus of centers of some circles which are always orthogonal to these two circles. For example, this is one of such circle. Means these two circles are orthogonal and these two are orthogonal. Then center of this circle will lie on the radical axis of these two circles. Listen, the locus of centers of circles which are orthogonal to S1 equal to 0 and S2 equal to 0 is the radical axis of S1 equal to 0 and S2 equal to 0. Means there exist infinitely many circles. So all the centers will fall on the radical axis of S1 equal to 0 and S2 equal to 0. Means what? That is nothing but radical axis. Locus is nothing but radical axis. Okay. For example, this is S1 equal to 0. This is S2 equal to 0. So this is S equal to 0. Now, for example, these two circles are orthogonal and these two circles are orthogonal. Now it is better to prove that this center is lie on the radical axis of S1 equal to 0 and S2 equal to 0. I will prove here. So this is circle S1 equal to 0. So this circle S2 equal to 0. Okay. This is another circle. Say SC equal to 0. One of the circle. There exist infinitely many circles which are orthogonal to these two. One of such circle. Okay. Now I want to prove that center of this circle will fall on the radical axis of S1 equal to 0 and S2 equal to 0. Okay. Given, what is given? Given S comma S1 and S comma S2 are orthogonal. You can write it 0 also, are orthogonal. Means at the point of intersection, if you draw tangents, for example, this is tangent to circle S1 equal to 0. This is the tangent to circle S1 equal to 0. This is tangent to circle S equal to 0. This is the tangent to circle S1 equal to 0. So that they are perpendicular because given that they are orthogonal. Observe here. This is the tangent to circle S1 equal to 0. This is a point on the circle S1 equal to 0. Through that point, a line drawn perpendicular to this tangent, that being normal to the circle S1 equal to 0, that should pass through center of the circle. So this line will pass through center of the circle S1 equal to 0, say C1. Okay. Now, so this is the tangent to the circle S equal to 0. This is a point on the circle S1 equal to 0. Through that point, a line drawn perpendicular to the tangent that should pass through center of the circle only. No? Means if you extend this will pass through center of the circle. So what it shows, this is not radius of S equal to 0. Sorry, S equal to 0. Now, this is the tangent for S equal to 0. This is the tangent. This is the tangent for a circle S2 equal to 0. Given that they are orthogonal. Here 90 degree, here 90, here 90. The same argument. This is tangent for S2 equal to 0. This is a point on the circle S2 equal to 0. Through that point, a line drawn perpendicular tangent will pass through center of the circle. It will pass through center of the circle. Next, this is tangent to s equal to 0. This is a point on the circle s equal to 0. Through that point, a line drawn perpendicular to the tangent. It will pass through center of the circle. So this line also passes center of circle. The point of intersection of this tangent and this tangent is nothing but the center of the circle s equal to 0. So what happened now? This is radius of s equal to 0. This is the radius s equal to 0. Same circle, no? Their radius should be same. Means this length should be equal to this. Again, what is this? This is tangent from this point to this circle. Line is nothing but tangent to s2 equal to 0 drawn from the center of s equal to 0. Through this point, tangents are drawn to both the circles having same length. Radii, no? Same length. Means what happened? This is a point on radical axis of s1 equal to 0 and s2 equal to 0. So there exists infinitely many circles. All the centers will satisfy this condition. All the centers will fall on radical axis of s1 equal to 0 and s2 equal to 0. Therefore, locus equation is nothing but radical axis of s1 equal to 0 and s2 equal to 0. Sometimes they will ask problems like this. Find the locus equation of centers of all the circles which are orthogonal to s1 equal to 0 and s2 equal to 0. Just find radical axis equation of s1 equal to 0 and s2 equal to 0. Okay students, we have two example problems here. First one is find the equation of radical axis for these two circles. Just s1 minus s2. But should take care. So the coefficients of x square and y square should be same. Here 2, here 2. Here should be 2, 2 or both should be converted 1. So while subtracting one from other should get a linear equation. So first of all, I want to write S1 as solution for first problem. Now I am rewriting S1 as x square plus y square plus 3 by 2x plus 3y minus 5 by 2 equal to 0. Second, x square plus y square minus 7 by 2x plus 8 means 4y, sorry, 8 by 3, no? Okay. 8 by 3y minus 11 by 3. I think here also 7 by 3, not 2. Okay. Equal to 0. Yeah, minus 7 by 3, 8 by 3. Radical equation, radical axis. Radical axis. Axis means only one, no? Radical axis is s1 minus s2 equal to 0. Subtracting. So what happened, Anna? 3 by 2 plus 7 by 3 times of x plus 3 minus 8 by 3 times of y. Yeah. Next what plus, no? 11 by 3 minus 5 by 2 equal to 0. This is the radical equation. Now I want to simplify. 9 plus 14 by 6 into x plus 9 minus 8 by 3 into y plus 22 minus 15 by 6 equal to 0. So 9 plus 14, 23x plus 2y, yeah, plus 5, 7 equal to 0. This is the equation of radical axis. Okay, cross check my calculations may be wrong. Okay students, our second example. If radical axis of these two circles touch this circle, means radical axis is tangent to third circle. So such a way that you want to find g and f values. Observe here, two circles are given. You can find the radical axis. The radical axis touching to another circle means tangent to another circle. So when this happens, Nana, distance from center to that line should be equal to its radius. First of all, you want to find equation of radical axis for these two circles, but they are not in standard form. I want right order. S1 equal to x square plus y square plus 2gx plus 2fi plus c equal to 0. S2 circle is, I want to divide by 2, x square plus y square plus 3 by 2x plus 4y plus c equal to 0. Radical axis is just subtraction. So what happened here? 2g minus 3 by 2 into x plus 2f minus 4 into y. CC get cancelled equal to 0. This is the radical axis, given that this radical axis tangent to another circle. So given this is tangent to which circle? X square plus y square plus 2x plus 2y plus 1 equal to 0. Its center is minus 1 comma minus 1. Radius is root over 1 plus 1 minus 1, 1. Just we want to find distance from C to this radical axis, and equating to 1 we get the required values of f and g. So distance directly minus into this 3 by 2 minus 2g plus minus with this minus 4 minus 2f plus c not there mod by root over 2g minus 3 by 2 square plus 2f minus 4 whole square should be equal to 1. We need to simplify this. Okay, directly squaring 3 by 2 minus 2g plus 4 minus 2f mod square equal to 2g minus 3 by 2 square plus 2f minus 4 whole square. Yeah, directly what I can say, 3 by 2 minus 2g whole square plus 4 minus 2f whole square plus 2ab, 2 into modulus of 3 by 2 minus 2g into 4 minus 2f equal to this 2g minus 3 by 2 whole square plus 2f minus 4 whole square. I mean this get cancelled. So what is the meaning of this? This should be 0. That is 3 by 2 minus 2g into 4 minus 2f equal to 0. Means what happened? 3 by 2 minus 2g equal to 0 or 4 minus 2f equal to 0. So directly g is equal to 3 by 4 or f equal to 2. Okay students, so here are two more example problems. Example 3, find the locus. Locus problems are important, Nana. Find the locus equation of a point which moves such that the tangents drawn from it to these two circles are equal. Just to we want to find radical axis. Just to we want to use definition of radical axis, we can say that the required locus is nothing but radical axis. Next question. The ratio, this problem you can do. The ratio of lengths of tangents drawn from the circle. One circle is given here. Two more circles are given. So take any point on this, draw tangent to first circle as well as second circle. We want to find the ratio of their lengths. This length divided by this length. Important thing is any point you can take from this circle. From that point, tangents are drawn to the given circles. We want to find the ratio of length of the tangent segments. So here interesting thing is first circle is 15x square plus 15y square minus 48x plus 64y equal to 0. Any point you can take, the ratio should be same only. But I will take convenient point. This circle is passing through origin. Observe, no constant. So I will take 0, 0 only the point. Convenient point. Take other than 0, 0. Take any point. The ratio should be same. But convenient point should take, that is 0, 0. Now from 0, 0 I want to find this length. This is the root over s double 1 for this circle with respect to that point. So I can say this is a P, this is a B, PA. Directly root over first circle here. 5x square plus 5y square something is there. 0 comes substituted. 0, 0, 0, 0, just 75. PB. Same. 0, 0, 0, just 300. My required ratio is root over 75 by root over 300. Okay students, this is root over 25 into 3 by root over 25 into 12, that is root 3 by root 12, that is root 3 by 2 root 3, root 3 get cancelled, 1 by 2 means 1:2, the required ratio is 1:2. Take any point on the circle other than 0, 0 and find out your ratio should be 1:2 only.